Welcome to the unboxing and complete features description of ASRock X570 Creator motherboard. As its name suggests, this motherboard is focused on content creators, artists, researchers, and other people who need exceptionally fast connectivity to move large amounts of data. Two of its key features are two Thunderbolt 3 ports and 10 Gbit LAN port. It's mainly a workstation motherboard. It doesn't mean that you can't play games on it. Of course you can, like you could on any other X570 board. There is no exception. It would be just an unnecessary overkill. What really separates it from other X570 boards is the integration of this connectivity, which frees PCI Express 4.0 slots instead of using them to allow this connectivity, like is in case of other manufacturers. Because of how feature-rich this motherboard is, I suggest that you pause the video, get yourself a cup of coffee and some snack, because this is going to be a long one. I take it that you are ready now, so let's get to it. So let's have a look at what you get inside the package. A quick installation guide, software setup guide, memory setup guide, CD with drivers and utilities, and a sticker. A right angle mini DisplayPort to DisplayPort cable, two M.2 screws and two M.2 standoffs, an I/O shield, SLI bridge, Wi-Fi antenna, 4 SATA cables, and the motherboard itself, ASRock X570 Creator. Let's have a look at the cables again, now from a different perspective, with the measurements. The Wi-Fi antenna cable is 1 meter long, and this stand and double-sided sticker was included, so you can stick it on any surface. Then there are these 4 SATA cables, which are 50 centimeters long, and 2 of them have 90-degree connectors. And the last cable is this mini DisplayPort to DisplayPort cable, which is 23.5 centimeters long. Let's begin with the rear I/O. It isn't covered by an integrated shield, so you'll have to use the one which was enclosed with the accessories and put it in place ahead of installing the motherboard. It's a little surprising, especially at this price point, that it isn't integrated, but it has no effect on the functionality, and the build quality looks fine. It has this nice cushioning, so I think we can live with that. When we start from the left, the first is Flashback button. It allows you to update the BIOS without powering on your PC and even without having the CPU installed. There is a good chance you might really use it because the pre-installed BIOSes on all motherboards are usually outdated. This is caused by a time gap between the production of the motherboard and its distribution to the seller and the final delivery to you. This process can even take several months. The development of new versions of BIOSes is ongoing, bringing more stability, compatibility, and adding new features. So, how do you know which version of BIOS you have without having to boot up the PC? The motherboard has a small sticker with the number of its version of BIOS with which it was shipped. It's located here, so you know immediately which version you have. In my case, it's P130. New Ryzen 5000 series CPUs came out recently, so it's probable you might use this feature. Therefore, I'll give it more space in this video so that you don't have to search what to do in the manual or online. When we look at ASRock's website, at the time of making this video, the most recent version of BIOS available was 3.13. So you'll need to download it and make sure you have a flash drive. The flash drive has to be formatted to FAT32 file system. Then you'll have to extract the BIOS file. The last one has 33.5 megabytes after extraction, and rename it to creative.rom. Then you'll plug in a 24-pin power connector to the motherboard, turn on the power supply, there is no need to power on the system, plug the USB flash drive to USB BIOS flashback port, press flashback button for 3 seconds, then the light will start blinking and you'll just wait until it stops. Easy. Also, make sure you don't turn off the power while it's flashing. It would corrupt the BIOS. It's very important. Then we have here 2 antenna ports. The Wi-Fi chip, which is connected to these antenna ports, is an Intel Wi-Fi 6 802.11ax. It supports 2.4 and 5 GHz dual band. It also features Bluetooth 5.0 module. The antenna, which was part of the accessories, is made of plastic and it's possible to attach it to its plastic stand, which will help keeping it in straight position. After successful attachment to the base, it will make a clicking sound. Thanks to the 1 meter long cable, you'll be able to place it on top of your PC or attach it to the desk or any furniture close by for the best signal reception. I wish all manufacturers provided this long cable with their antennas. Here is a PS2 mouse and keyboard port. When I'm looking at it, I feel a little nostalgic. It's surprising ASRock went for this option. Nowadays, both mice and keyboards are usually connected to USB ports. Anyway, those who still use their older devices can keep using them without any adapters. Under it, there are 2 USB 3.2 Gen 1 Type A ports. When we move to the right, there is a DisplayPort input version 1.4. The maximum supported resolution goes up to 4096 by 2160 at 120 Hz. This is for receiving the signal from your GPU and sending it to this Thuderbolt output, which will allow you to connect your monitor if it has USB Type-C Thunderbolt input. Under it, there is an HDMI port. It's version 2.0 with maximum resolution going up to 4096 by 2160 at 60 Hz. It will work with an APU. APU is a term created by AMD in 2011, which stands for Accelerated Processing Unit, which is a CPU which has integrated graphics. This means that you would have to use Picasso or Renoir APUs to make use of it. Here are 4 USB 3.2 Gen 1 Type A ports, which means that their speed is 5 gigabits. Under them, there are these 2 USB Type-C ports. They can run either on Thunderbolt 3 protocol, which can achieve up to 40 gigabits per second throughput, or USB 3.2 Gen 2 protocol, which can use maximum speed of 10 gigabits per second. The right USB Type-C port can also be used as an output for a GPU if it's connected to the internal DisplayPort connector by the provided mini DisplayPort to DisplayPort cable. Unfortunately, the only GPUs which have this option are made by ASRock, so only very few people will be able to make use of it. Above the USB port there are these two LAN ports. The left one, black one, is Intel i211AT and it's 1 gigabit, and the right one is 10 gigabit Aquantia AQC107, which is one of the main features of this motherboard. Aquantia chip for 10 gigabit LAN card is hidden under this heatsink. Now let's have a look at the audio. At the bottom there is an optical digital output, and close by are these 5 golden plated HD audio jacks, which are connected to Realtek ALC1220 audio codec, which provides decent audio quality, but those who are more into music and sound will probably use a standalone PCI Express sound card anyway, or will use optical digital output to get the sound signal out of their PCs into some higher-end external sound card. When we look at this side of the motherboard, we can see large VRM heatsink, which is made of aluminum alloy and has an embedded heat pipe. I like that it's beefy because it will keep VRMs cool and therefore will help the stability of the system. Under it are 14 phases of VRMs using an IR35201 voltage controller. 12 phases are for CPU and 2 for SoC. This tells us that it's actually 6.2 phase VRM config that makes use of IR3599 doublers to increase the phase count for 12 volt phase. It's an overkill, but most high-end X570 boards are equipped this way. I think it would be interesting to see if it's going to interfere with large CPU cooler like Noctua NH-D15. So let's try it. It doesn't interfere, so it's possible to use it. There are still few millimeters above the VRM heatsink, so it's not a problem. And also the CPU isn't installed, so that's another factor which would add at least 2 or 3 millimeters. This is an AM4 socket. The motherboard supports 2nd gen, 3rd gen and 4th gen AMD Ryzen CPUs. To use 4th gen or Ryzen 5000 CPUs, you will need to update the BIOS. The PCIe bandwidth is dependent on the CPU installed. Using 2nd gen CPUs, or in other words, Ryzen 2000 series, will disable its PCI Express 4.0 capability, so using it would make no sense, because it's the main reason for using a motherboard with X570 chipset. If you're thinking of using this motherboard for a video editing setup or for rendering, I would strongly suggest that you focus on CPUs which have 8 cores or more. And take into consideration that you won't be able to upgrade for anything better than 5000 series, because those are the last CPUs for this AM4 socket. The motherboard has 4 DIMM slots and supports dual channel memory setup. It supports DDR4 memory modules at speeds up to 4666 MHz. Maximum overall supported memory capacity is 128 GB. 32 GB single DIMMs are the max. ECC memory modules are also supported. I recommend checking QVL first to make sure the ones you chose are compatible. If you're using only 2 memory modules in dual channel setup, you should place them in slots A2 and B2. That means these 2 slots according to this scheme on the motherboard. You cannot use dual channel memory setup with 1 or 3 memory modules, and in my opinion you shouldn't use single channel at all, because it has dramatic impact on the memory throughput of the whole system. It would be like having a sprinter and cutting him one leg off before the race. Here are 2 12-volt power connectors, an 8-pin and additional 4-pin. It's a complete overkill. 8-pin can deliver over 380 watts, so it would have been more than enough. Next to them is a 4-pin PWM fan header, and here are another 2 PWM fan headers, and these are for the CPU. Close to them is this LED RGB header, non-addressable. Altogether, this motherboard has 3 RGB headers, 2 non-addressable and 1 addressable. You can control RGB LED lighting from within the UEFI on the basic level, and you can also download ASRock's Polychrome Sync utility to do this in OS. Now let's have a look at the right side of the motherboard. Let's start from the right. Here is the main 24-pin power connector. Next to it is a USB 3.2 Gen 1 header. It can provide up to 2 USB ports. Here is a fourth PWM fan header. This is a front panel USB 3.2 Gen 2 header. You'll connect your case cable here. If you haven't bought a case yet, I recommend you buy one which has USB 3.1 or 3.2 Gen 2 front USB-C port. It's really useful. Remember, you want the one which has Gen 2 port, not Gen 1. If you already have a case which doesn't have one, you can buy this and place it at the back of your case so that you are able to make use of it. It's better than nothing. Also, if you're interested, you can find a test of USB-C 3.1 Gen 2 external cases on my channel. They can be very useful for quick data transfers or a backup. Here are 8 SATA ports. The numbering is visible on the PCB, which is a good idea. The first 4, that means these, support RAID 0, 1 and 10, and the other, that means these, don't, because they are connected to ASMedia ASM1061 chip, which doesn't support it. Anyway, it's nice to have so many available ports for SATA SSDs or hard drives. Let's turn the motherboard and have a look at the bottom part. This is a clear CMOS button. It allows quick clearing of CMOS values, or in other words, resetting the values in BIOS. This function will work only when you power off your computer and unplug the power supply. Another way of doing the same thing is using clear CMOS jumper, which would be used here. And to do it, to clear and reset the system parameters to default, you also need to turn off the computer and unplug the power cord. Then use a jumper cap or a screwdriver or anything metal to short the pins for 3 seconds. If you use the jumper cap, remember to remove it after clearing the CMOS. If you need or want to clear the CMOS after you've just finished updating the BIOS, you must boot up the system first and then shut it down before you do the clear CMOS action. This is important. First boot up and then reset. This is a system panel header. It allows you to connect power button, reset button, system power LED and hard drive LED from your case to the motherboard. You have to make sure you match pluses with pluses and minuses with minuses when connecting the wires, so check the manual first. This is a power LED and speaker header. Normally it's a part of system panel header, but they divided it into 2 parts here because there isn't too much space here at the bottom to have them in one piece. That's also probably why they didn't provide a uniting plastic connector for the wires. Next to the system panel header is this power button, reset button, and postcode display. It can be great help with potential debugging. ASRock invented an original name for it, calling it Dr. Debug. Next to it is this 5th and also the last fan panel header, also PWM. Next to it is this USB 3.2 Gen 1 header. It can provide up to 2 USB ports. And here is USB 2.0 header. It also provides up to 2 USB ports. Next to it is this RGB LED header, addressable, and close by is this non-addressable RGB header. Here is a TPMS1 header. It's not listed in the manual. TPM stands for Trusted Platform Module. It is a microchip which provides hardware-based cybersecurity and authentication. To use it, you must have one. This one has 17 pins and 1 blank. Why it's not listed in the manual, I have no idea. There is also a second TPM header called SPI TPMJ1, which is here, and it has 13 pins and one blank. And the last header on this side of the motherboard is this front panel HD audio header. When we look at the motherboard from this point of view, we can see 3 PCI Express 4.0 X16 slots, which are reinforced by steel. ASRock calls them steel slots. The first 2 PCI Express 4.0 slots are connected directly to the CPU. When you occupy only the first one, it will run at full X16 speed, and when both of them are occupied, they will run at X8 speed each. The third PCI Express 4.0 slot is X16 in length, but runs only at X4 speed effectively because there are only 4 PCI Express lanes leading from it to the chipset. It's not connected directly to the CPU. From the chipset, it's connected by 4 PCI Express lanes to the CPU, which means that it's sharing bandwidth with the second M.2 socket with PCI Express 2.0 X1 slots and with all SATA ports. Then we have here 3 PCI Express 2.0 slots X1 which are not reinforced by steel. They can be used for devices which don't require a lot of bandwidth, like sound cards, Gbit LAN adapter or LPT reduction card for old printers. Because of the size of today's GPUs, which take usually from 2 to 3 slots, it's probable the first 2 won't be used at all, which is something that was accounted for. Then we have here 2 M.2 sockets for NVMe SSDs. ASRock calls them Hyper M.2 sockets. Both sockets are covered by metallic heatsinks with pre-applied thermal pads. So let's remove the heatsinks and have a look at what's under them. My inbuilt weighting mechanism is telling me that this heatsink weighs 30 grams. And let's check out the second one. And this heatsink weighs 95 grams. So they are pretty heavy, and it's good because it's good for the cooling. First M.2 socket is called M21. It's connected directly to the CPU by 4 PCI Express 4.0 lanes, which means that it's the best one to use with Gen 4 drives because it will be able to run at its full speed and won't be sharing the bandwidth with any other sockets or slots. It supports 3 sizes of M.2 NVMe SSDs, 2260, 2280 and 22110. 22 is the width of the drive and 110 is the length in millimeters. So it supports these 3 sizes. The second M.2 socket is called M22. It's connected first to the chipset and from there by 4 PCI Express 4.0 lanes to the CPU, which means that it's sharing this bandwidth with all PCI Express 2.0 slots with PCI Express 4.0 slot running at X4 speed and with all SATA ports. It supports 5 sizes of M.2 NVMe SSDs, which means it's 2230, 2242, 2260, 2280 and 22110. If the shared bandwidth from the chipset to the CPU is affecting your use case too much, you should probably think about Threadripper because it has 8 PCI Express 4.0 lanes from the chipset to the CPU. On the other hand, in most common use cases, you don't really read from or write to an NVMe drive and all SATA drives or any other drives which could be placed in an edit PCI Express card at the same time continuously. So this limitation of 7.8 GB per second from the chipset to the CPU may not take any effect in real life. The last thing we haven't talked about is the chipset. It's under this heatsink. The fan on the heatsink can be speed controlled, and I think it's probably the first thing you should do after entering the BIOS, to set it to silent profile. Otherwise the fan speed will be too noisy and will disturb you. I think this is everything I wanted to talk about on this side of the motherboard. So let's turn it around and see what's there. As we see, the motherboard doesn't have a large metal backplate, so be careful when handling it inside the case. Make sure you don't drag it by the standoffs and peel off the chips from the PCB. The backplate, which is under AM4 socket, is made of metal and looks solid. And last but not least, my inbuilt weighting mechanism is telling me that this motherboard weighs 1195 grams. Now that you know what this motherboard offers, you might be thinking, is this for me? Well, let me make it simple for you. If you're running 10 gigabit network and using Thunderbolt 3 accessories, this probably might be the best option on the market. Also considering that it's only standard ATX size, so it doesn't require you to buy a large PC case, as would be the case with other similarly equipped boards, because they are usually eATX size. I like its simple design, connectivity, and I would say the overall value proposition. I think the price is adequate to what it offers. On the other hand, if you're not using these features, I think you'd be better off not getting this motherboard, because it would be an unnecessary overkill. I'll likely be adding a standalone PCI Express card to extend its possibilities when it comes to housing M.2 NVMe drives. So this card will allow me to add another 4 M.2 NVMe drives, and I'll probably be using, or not probably, surely be using standalone sound card as well to match my sound quality requirements. And when I think about it, I think I have covered everything. So if you have any questions about this motherboard, let me know in the discussion below this video. I'll do my best to answer. And I think this is really it. So thank you for watching, and see you in the next video.